All right, in this video, we're just going to look at the pink section of your rainbow review. So in number 1, we want to sketch a graph of the function 2 divided by x. Now an easy way to do this would just be to set up like an xy table. And you remember that the parent function is going to look something like this. And so we're going to have the two branches in, because nothing's changing here, there's no negative, so it's not flipping or anything. So there's going to be two branches in quadrants 1 and quadrants 3. So I'm going to set up, like I said, an XY table. And I'm going to use some numbers like, use some positive numbers. Well, because I want to use something simple that I know that is divisible by 2. So 2 divided by 1 would be 2, and 2 divided by 2 would be 1. So when x is 1, y is 2. When x is 2, y is 1. So I could just sketch this branch to look something like that. And then the other branch, I'm just going to use some negative numbers because I know it's going to be where x is negative, so I'll just use -1 and -2. So when x is -1, 2 divided by -1 is -2, and 2 divided by -2 is -1. So when I find those coordinates, so -1, -2 would be here, and -2, -1 would be here. So then we sketch our graph like that. Close enough. All right, so your domain for this. Remember we have our asymptotes here. Your asymptotes would be these two lines. So actually, let's start with the asymptotes. So the horizontal asymptote, that is going to be where it crosses the y-axis. So the horizontal asymptote is at y equals 0. The vertical asymptote is where it crosses the x-axis. So that's going to be at x equals 0. Remember, the asymptotes represent the values that we can't use in our domain and range. And so for our domain, for our restriction on our domain is we would say it's everything except x can't equal 0. And for our range, we would say that it's everything except y can't equal 0. So that would be how you find your answer for number 1. So with number 2, this involves a translation. Okay, so this means that we're going to move the graph to the right 3 units, and this means we're going to move the graph up 4 units. Well, if we move the graph to the right 3 units, that means that vertical asymptote is also going to move to the right 3 units. So I'm going to start by drawing my asymptotes. It makes it a lot easier. And then it's going to go up 4 units. So I'm going to draw my horizontal asymptote. That would be affected by moving up 4 units. And now I can sketch my graph. Remember, it's going to go through these 2 points that are only 1 unit away from that origin, to the left and right of that origin. And so I'm just going to sketch a point. I'm going to sketch a line that would go through that new point. And so then again, let's start with our asymptotes for this one. So we would have our horizontal asymptote is a line that goes through the y-axis, and it goes through the y-axis at y equals 4. Our vertical asymptote is going to be the line that goes through the x-axis, and it goes through the x-axis where x equals 3. So our domain is our set of x values, so we know that x can't equal 3 then. And our range is our y values, and we know that y can't equal 4. So personally, I think it's always easiest to start with your asymptotes because that'll help you identify what your domain and range can't be. All right, so let's look at this one. So again, we know the parent function for this would be y equals 1 over x. And so we want to figure out what would be the equation for this new graph. Well, let's identify where those asymptotes would be. So here's our horizontal asymptote. Here is our vertical asymptote. So I can see that this graph is moved to the right 1 unit, and it's moved up 2 units. Okay, so if it's moved to the right 1 unit, that means that we would have x minus 1. Because remember, what happens to the x is actually the opposite of what we would expect. And so x minus 1 would mean that it moved to the right 1 unit. And then it moves up 2 units. So then we would just write down plus 2 here. So that would be your function for that graph equation. All right, looking at these variation problems, let's look at 4a. Suppose y varies inversely with x. Write an equation that models each inverse variation and find y when x equals 2. So that's just a typo there. So we know that x is 7 when y is 4. Okay, so the first step is to write your general equation. y varies inversely with x. So it'll be y equals k over x. Our second step is to figure out, well, what's our value for k given the information that we have. And we know that x equals 7 when y equals 4. So I'm going to put 4 in for y, and I put 7 in for x. So to solve this, I would multiply both sides by 7. So we would get k equals 7 times 4, which is, 28. So now we know our value for k. Our third step is now we can write a specific equation, because we know our value for k would be 28, so it'd be y equals 28 divided by x. So then your final step would be to answer the question. And the question is, find y when x equals 2. So if we put 2 in for x, we get 28 divided by 2, so we get y equals 14. So these are ones that we can solve in 4 steps. All right, let's look at number 4, letter B here. So if you're just jumping into this video, we're going to do this in 4 steps. So the first step would be to set this up as a general equation again, y equals k over x. Again, the reason why we have that is because it says y varies inversely with x. Anytime we see that phrase varies inversely, it means equals k divided by something. All right. Second step is to set this up, or we're going to plug in what we know. Okay, we know, so we have our general equation, y equals k over x. Our second step is we know x is 3 when y is 10. So I'm going to put 10 in for y. And we're going to put 3 in for x, because our purpose in the second step is to figure out what's our value for k. So if I solve for k, I multiply both sides by 3, so I get k equals 30. So now that we know our value for k, we can plug that in to get a specific equation. So we're going to go back to what we had in step 1, our general equation, to say y equals, but our k value is 30 this time. So we'd have y equals 30 divided by x. And we can use that specific equation now to answer the question. The question says, find y when x is 2. So we would have 30 divided by 2. So when you do that, 30 divided by 2 is 15. So you get 15 for this one. All right, so for number 2, letter C, this is the, or I guess in mine, I have, this is number 4, letter C. This is the last one in the pink section. So again, we're going to solve this using this 4-step method. So the first step is to write a general equation. At the beginning there, remember it said y varies inversely as x, so it'll be y equals k over x. So the second step, we're going to solve for k using the specific information they gave us. So we know y is 20 when x is 12. So we'd have k divided by 12. So to find k for this one, we're going to multiply both sides by 12. So when you do that, you get a k value of 240. So now that we know what our value for k is, we can write a specific equation. Instead of y equals k over x, we could say y equals 240 over x. And then the last step would be to answer the question. Again, the question is up here, find y when x equals 2. So I'm going to put 2 in for x, so to our specific equation there. So 240 divided by 2 tells me that y would equal 120. So that's how you would do that last problem.